the name of the technique tells you about the work that you are doing involving fractions or in the quotient form. Okay, so gonna be some quantity over another quantity. So in this case, you're gonna have to identify the integrand as the proper fraction. So let me do this. So number one, so it has to be a proper fraction. What does it mean by a proper fraction? The proper fraction means the numerator has less power than the denominator, like the quantity to the power n divided by the quantity to the power m, where n is the leading power of the top and m is the leading power of the bottom. So n has to be less than the number or the number m. Okay. For example, if you have the expression x squared plus 1, the bottom has to be the power 3 or higher. So going to be x, like 2x to the third plus 4x squared plus 5, something like that. So this case, this is the proper fraction. So the improper means in the case that you still have like x to the 3 plus to the power 3 plus 1 to x to the third plus 4x squared plus 5. So this case is called improper. So if you have improper case or the power, they are not less, one is not less than the other, you're gonna do the long division procedure. So long division that we can work on some problem in a bit. So number one has to be proper fraction. And then the next step, what we're gonna do after we have the proper fraction within the integrand. So step number two, we're gonna have to work on the factor the denominator completely. Okay, so factor the denominator. Okay, factor the denominator, and it could be in the case of the linear factor or the quadratic factor. What does it mean? Linear factor, that means you factor it out into small factors, and then the power of the x is the first power for each term. So it doesn't matter you have the coefficient in front of it or not coefficient, but the power of the x gonna be 1. So these are called linear factor. For the quadratic, it's called the irreducible quadratic factor. In the case that you have x squared plus 1, this is a quadratic factor, so you cannot factor anymore. So it has to leave it as the group of the highest power 2. Okay, so two cases, either linear factor or quadratic factor. And then you're gonna do the partial fraction. That means you're gonna break it up. And the process is called partial fraction decomposition. Decompose, or like if you have the fraction in one quantity, you're gonna break it up into small one, adding together. Okay, adding into small pieces. And why we have to do that? Because if you have the complicated fraction to begin with, when you decompose them, it's going to be easier or less complicated to find the antiderivative. So that's the point of the partial fraction. Okay, and then another part of the partial fraction technique. So if I go back to the form here in the PowerPoint, for the linear factor rule, the linear factor case, the denominator was decomposed into small factors and they all are linear. And at the power m, you're gonna break it as the small fractions up onto the power m. For example, you have 1 over x plus 2 to the power 3. You're gonna break it up as the x plus 2 to the first power, x plus 2 to the second power, x plus 3 to the third power, and the numerator gonna be undetermined, the one that we are going to find out. So this is what it means by linear factor rule. When the denominator is the linear raised to the power m, you're gonna have m partial fractions, starting from the power 1, power 2, up until power m. And similar to the quadratic factor rules, the quadratic factor rule for the denominator in the form of ax squared plus bx plus c up until the power m. So you're going to start with the first fraction, power 1, denominator power 1, denominator power 2, up until power m. And then the numerator going to be a little bit more complicated than the case of the linear factor, because we're going to need each one in the proper fraction form. Excuse me. That means if the bottom is considered as a quadratic factor, so the power of the bottom is 2. So the top, the numerator has to be the power up until power 1. So we're going to have to put like all possible cases that the numerator could be. So for the first fraction, we're going to have the a1x to the first power plus b. And then the next can be a2x plus b2 to the divided by the quadratic power 2 and so forth, where the factor, the linear factor has just the constant, and on the note I use a1, a2 up until am, but on the example here I use a, b, c. So you can use either notation to represent the constant. So when I work on the problem example, I always use the ABC just to minimize the confusion, just in case you miss the subscript and then you get all things messed up. So after you get that, you're gonna set the original fraction, the f over g, equal to the sum of all of these partial fractions. Okay, and then you're gonna work on determine the coefficient. So this is the process of algebra that I will target on, or I work on more when we work on the problem. Okay, so let's see the first example. The first one said we're gonna use the partial fraction to evaluate this integral. And the integral, as you see, is in the fraction form. This one is considered a proper fraction because the numerator 1 means x to the 0 power. Okay, divided by 2x minus x squared, divided by 2x minus x squared. So the power 0 as a numerator power, 2 as the highest power of the denominator. So check because 2 is greater than 0. I mean the power compared with the power. That means this case, the integrand is already in the proper form. So check, we don't have to do the long division form. So then after that, we're going to factor the denominator completely. Factor x out, we have 2 minus x. With respect to x, we have two factors, each one. The first one is considered as x minus 0 to the first power, and this is 2 minus x to the first power. Both of them, they are called linear factor. Okay, linear factor, because the x to the first power, x to the first power here, and the m in this case, the m or the power of the entire factor, in this case is just 1. So what does it mean? It means you can do the expansion as the sum of the partial fraction just up to the power 1. We're going to do higher power in a little bit, okay? Just for this example. So then this one, we can break it up as the integral of, excuse me, one of them divided by x minus 0 or just x, plus the other factor is divided by 2 minus x. For the linear factor, the numerator going to be the constant. Either use a1, a2, or the a and b, it doesn't matter. So this is the next step after you have the proper fraction. This case, you do the process of decompose denominator. Decompose fraction, sorry, not denominator. Decompose fraction into the partial fractions. So to go forward after this, we're gonna sorry, so this delete, just add more room. From what we have so far, we have the integral I'm going to rewrite the problem, which is 1 over 2x minus x squared with respect to x. Now decompose into the integral of the a over x plus the b over 2 minus x with respect to x. So the next step, we're going to find the a and b value. So we're going to find a and b. And this process is called undetermined coefficient. And how do we find the a and b? Original expression is 1 over 2x minus x squared. The new expression is a divided by x plus b divided by 2 minus x. So we're gonna find the numerators of the a and b by recombine the two fractions. When you combine the fractions, you find the common denominator, right? In this case, the common denominator is x multiplied by 2 minus x. And then to combine them, so the first one, I'm going to need to multiply the top and bottom by 2 minus x, 2 minus x, where the second fraction, I have to multiply by x and by x to make the same denominator. So the first term gonna be a multiplied by 2 minus x. The second term gonna be b multiplied by x. At this step, I have the left and the right equivalent and the denominator are the same. That means my numerator must be the same. So the numerator on the left is 1. Numerator on the right is a times 2 minus x plus bx. And I'm gonna find the value a and b. You could do expanding all of them and then equate the coefficient, which so this is the first case, okay? B1 equals 2 times a minus a times x plus b times x. So that means I have the number, the standalone number as a 2x, and then the coefficient of the x as b minus a equals 1. And then the left-hand side is a constant term. So that means 1 plus the 0 multiplied by x, because no x term. Why I have to do that? Because I'm going to equate the coefficient of each term of the left and on the right. And how do I equate that? It's from, like, for the constant term and for the coefficient of the x term. So I categorize this way. For the coefficient, for the number, for the constant term, I have 1 equals to a, or a equals 1 over 2. So I have the number for a for the first fraction. And then for the coefficient of the x, I'm going to use to highlight different color. So the coefficient of the x is 0 and b minus a. That means I equate 0 and b minus a. Since a is 1/2, and from this relationship, we know that a equals b. B is 1/2 as well. Now we get the value for both a and b. So we plug it back into the name part of the problem. And the problem becomes the integral 1/2 divided by x plus 1/2 divided by 2 minus x with respect to x. Both of them have the same number, 1/2 as a coefficient. I get it out of the way. So going to be the 1/2 multiplied by the integral of 1 over x plus 1 over 2 minus x with respect to x. The problem gets cleaner. After the problem gets cleaner, at this step forward, you can find the antiderivative of each term. The integral of 1 over x is natural log absolute value of the x. The second term, you're going to use a u-sub. It's a very small process of using u-sub. U is 2 minus x. So that means the differential u is negative dx. So be careful. When you replace the dx, you're going to replace with negative du. Therefore, the second part here going to give you negative natural log of the absolute value of 2 minus x. And then you finish up by adding by c and you are done. So this is the answer of the second one. So I was mentioning about the way to find the a and b, or the what do you call the numerator part of the partial fraction. So this is one of the way. So I show you another way that you can do, and depends on which way that you feel more comfortable when you work on the problem. Okay. So another way that you could do for finding the do the partial fraction from what we have is 1 over 2x minus x squared, which from rewriting as the same denominator, or a times 2 minus x plus bx, all divided by x times 2 minus x. And the numerator here, when we equate 1 equals a times 2 minus x plus bx, this part is the numerator, right? Numerator. So one of the common ways to work on this problem is you're gonna kind of eliminate the quantity A or quantity B one at a time. If you choose the value x as the value 0, replace it for the entire equation, you're gonna get 1 equals a times 2 minus 0 plus b times 0, which gonna give you 1 equals 2 times a, or solve for a to get a equals 1 over 2. You get one number out by eliminating the bx, or take away the bx by replacing the number that get the bx out of the way. And similar way, now you pick another number. If x is 2, what happens to my equation? I will have 1 equals a times 2 minus 2 plus b times 2, or 2b. In this case, I eliminate the group of the a, so a is gone. Then I have 1 equals 2b, and solve for b to get b equals 1 over 2, the same result as what I did with the other way. So there are more than one way to determine the numbers a and b, or the numerator part of the partial fractions.